We live our entire lives on it. We work on it, we fall in love on it, and right now, you are watching this video on it. But if I asked you to point to the internet, where would you point? Most people point to the sky. We talk about the cloud, we talk about Wi-Fi signals floating through the air. We imagine the internet is this invisible, magical ether that surrounds us. But that is a beautiful lie. The internet isn't a cloud. It is a wire, a very, very long wire. It is a physical, heavy, industrial thing buried deep underground and lying on the dark bottom of the ocean. Welcome to Simple Things Surprising Histories. Today we are going to pull back the curtain on the most complex machine humanity has ever built to find out how a selfie travels from your phone to London in milliseconds. This is how the internet actually works. Let's start with the hardware. If you want to understand the internet, you have to ignore the Wi-Fi router in your house for a moment. That's just the last few feet of the journey. The real internet consists of hundreds of thousands of miles of fiber-optic cables. These aren't much thicker than a garden hose, but inside, they hold strands of glass as thin as a human hair. Here is the surprising statistic. Roughly 99% of all international data, every Netflix movie, every financial trade, every email, travels through cables underwater. Right now, there are over 500 active submarine cables stretching across the Atlantic, the Pacific, and everywhere in between. These cables connect to massive buildings called data centers. These aren't magical clouds. They are loud, hot, warehouse-sized buildings filled with computers called servers. Think of a server as a digital library. It stores the websites, the videos, and the files. When you want to see a website, your computer is essentially asking a server to send a copy of that website to you through those cables. So the internet is physically a web of glass wires connecting your house to a warehouse in Virginia or Dublin or Tokyo. Okay, so we have the wires, but with billions of computers and servers connected to this web, how does your information don't get lost? If you type youtube.com, how does the signal know which server to go to? It works exactly like the postal system. Every single device connected to the internet, your phone, your laptop, and the massive servers has a unique identification number. It's called an IP address. It looks like a string of numbers like 192.168.1.1. But humans are terrible at remembering long strings of numbers. You don't want to type 172.217.16.46 just to search for a recipe. You want to type google.com. This is where one of the unsung heroes of the internet comes in, the DNS, or Domain Name System. Think of DNS as the phone book of the internet. When you type google.com, your computer secretly contacts a DNS server and asks, "Where does Google live?" The DNS looks it up and replies, "Google lives at 172.217. This conversation happens in milliseconds before the website even starts to load. Without this directory, the internet would be unnavigable. Now we know where the data is going, but how does it travel? Let's say you want to email a high-resolution photo to your friend in Paris. That photo is a large file. If the internet tried to send that whole photo as one giant lump, it would clog the lines, like a semi-truck trying to drive through a drinking straw. So the internet does something brilliant. It smashes your photo into pieces. These pieces are called packets. Your computer breaks that photo down into thousands of tiny digital scraps. Each packet gets a label saying where it came from, where it's going, and crucially, which piece of the puzzle it is. Then they're launched into the network. And here is the wild part. They don't all take the same route. Packet number 1 might go through a cable in New York, while packet number 2 is routed through Miami because the traffic is lighter. They travel independently, bouncing from router to router across oceans and borders. When they arrive at your friend's computer in Paris, they might arrive out of order, Packet number 50 might arrive before packet number 1, but your friend's computer reads the labels, rearranges the packets back into the correct order, and boom, the image appears on their screen. This process happens so fast, you never even see the puzzle being put together. We often get frustrated when a page takes 3 seconds to load, but when you step back, it is nothing short of a miracle. In those 3 seconds, light has pulsed through glass strands on the ocean floor, machines have negotiated addresses, and thousands of tiny data packets have raced around the globe to reassemble a story right in front of your eyes. The internet isn't magic, it is glass, copper, electricity, and logic. But the fact that it works at all, that is the real magic. If you enjoyed seeing the invisible mechanics behind our digital world, please hit that like button. And don't forget to subscribe to Simple Things Surprising Histories for more surprising histories behind everyday life. Thanks for watching.